Okay, so we've got a non-uniform plank, which I'm just going to draw here. And we know that it's 12 metres long. And here's my point A, and here's my point B. It's non-uniform, so I'm going to just put the mass somewhere here. I don't know where it goes, but I just don't want to put it at the centre. There's my mass, and what I'm going to do is I'm going to define that centre of mass as a distance of x away from A. Now, in the first case, we know that a support is placed at the plank at point C, where AC is 3 metres. So we're going to put our pivot here, and we're going to make that 3 metres. And a child of mass 30 kilograms stands at A. So here I'm going to put a 30g force, and we're told that this is an equilibrium position. So we can use this to form an equation. So taking moments about C. Here, the distance from C to the centre of mass, well, this is x, but this is 3, so this distance here is going to be x minus 3. So the clockwise moment is x minus 3 times mg. Let me just make sure that that's done as a force. So x minus 3 times mg must equal the anticlockwise moment, which is 3 times 30g. Okay, that's going to come in incredibly useful in a second. I've now got exactly the same setup. So there's my A, there's my B, there's my centre of mass, mg, which it's the same plank, so we've still got that. Centre of mass is a distance x away from A, and in this case I'm putting a support over here where BD is 5 metres. This is my point D, and the child stands at B. The child is still 30 kilograms, so I've got 30g. And again, we're in equilibrium. Okay, so slightly more difficult, because what I need to do now is find the distance from the pivot to the centre of mass. Well, I know that the entire length is 12, so the length here from A to D must be 12 take away 5, which is 7. So this distance here must be 7 minus x. So that distance there is going to be 7 minus x. Just check that. X plus 7 minus x gives me 7, plus 5 gives me the 12 for the whole length. So that looks as though it's absolutely right. So taking my clockwise moments, I've got 5 times 30g equals my anti-clockwise moment, which is 7 minus x times mg. Perfect. So those are my two equations. I'm going to just multiply these out. Gives me mgx minus 3mg equals 90g, and here I've got 7mg minus mgx equals 150g. Notice I've got mgx in both equations. They're different signs, so I can add the equations together. That's going to cancel that out. So 7mg plus minus 3mg gives me 4mg equals 150g plus 90g gives me 240g. The g's cancel. I find out 4m equals 240, therefore m equals 60 kilograms. I now need to find out what x is, so I know that substituting back in 1, I've got x minus 3 times 60g equals 90g. Well, I can divide through by 60g, which gives me 1.5, so x minus 3 equals 1.5, therefore x equals 4.5 metres. And x is in fact the distance AG, which is very, very helpful for us. Okay, so for the last part of this question, we're told that we've got the support in both places. So we've got our support at C, which is 3 meters from A. So that's 3 meters. We've got our support at D, which is 5 meters away from here. And we're told that we know that the centre of mass here, so we've got our 60G force down here, and we know that that's 4.5 meters from A, so that's an additional 1.5 meters. We've got the child standing at E, so we're going to just place the child here, which is 30G. And we know that the reaction at both places, C and D, is the same. So there's my reaction at C, there's my reaction at D. And we're going to call that distance here from A to E, we're going to call as our distance x. So we're going to start by taking moments about C, and if I take my moments about C, my clockwise moments, I've got 1.5 times 60G from the 60G force. Now this distance here is going to be x minus 3, so plus x minus 3 times by 30G is equal to my anti-clockwise moment. So my anti-clockwise moment is going to be the distance from C to D. Well, the overall distance is 12, so here I'm going to take away 3, take away 5, it gives me 4 meters between C and D, so it's equal to 4r. Similarly, doing the same for, I'll simplify that first, so I've got 90G plus 30Gx minus 90G equals 4r. The 90G's cancel, so it tells me that 30Gx equals 4r. Doing the same thing around D, again I'll go clockwise. The only clockwise moment is from the reaction force at C, again that's 4 meters, so I've got 4r equals. Now this gets a bit more complicated, so here I know that my distance to the centre of mass, I've got 12 in total, take away 5 is 7, take away 3 is 4, take away 1.5 is 2.5, so the distance from D to the centre of mass is 2.4 times 60G. And this distance here, well, I've got rid of my 5, so 12 taken away 5 is 7, so this distance here must be 7 minus x, plus 7 minus x times 30G. So I can now say here that 4r equals 2.5 times 60G is 150G, plus 210G minus 30Gx, so 4r equals 360G minus 30Gx. I can now equate my equation 1 and equation 2. They're both equal to 4r, so I can say 30Gx equals 360G minus 30Gx. Bring the 30Gx to the other side gives me 60Gx equals 360G. Divide both sides by 60, divide both sides by G gives me x equals 6 meters. So the distance A is 6 meters. Well done.